simplify, we're rewriting with a single trigonometric function. So we see 2 sine squared of x plus 3 cosine of x minus 3 equals 0. So we notice we have two different trig functions. So since we have a cosine of x, the only one that we can change is the sine squared of x. So cosine squared of x plus sine squared of x equals 1. I'm going to change it to cosine, so sine squared. I'm going to subtract cosine squared of x from both sides, so I can replace the sine with cosine. So I'm going to replace sine squared of x with the 1 minus cosine squared of x. So this is now 2 times 1 minus cosine squared of x plus 3 cosine of x minus 3 equals 0. So then you simplify 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. So 2 minus 3, let's simplify further, negative 2 cosine squared of x plus 3 cosine of x minus 1 equals 0. So what you need to do is change this to a positive. So divide everything by a negative 1 to change the sign. So this is 2 cosine squared of x, negative 3 cosine of x, and a positive 1 equals 0. So change that. Make sure you do change that to a positive. So then let's factor it. So 2 cosine of x, so it's positive, so it needs to be 1, negative 1, and negative 1. So negative 2 minus 1 is a negative 3, so this is correct. And so now we factor like we did before. Use a 0. We factored like we did before, and now we're using the zero product property. So we see that 2 cosine of x minus 1 equals 0, and cosine of x minus 1 equals 0. So solve. So 2 cosine of x equals 1 divided by 2. So when does cosine of x equal a half? Then on this side, when does cosine of x equal 1? So we take a look at that. So x equals positive 1 here, and it equals a half in this quadrant and this quadrant. So that's at pi over 3 and 5 pi over 3. So instead of saying 0, we can say 2n pi here. So our answer is x equals pi over 3 plus 2n pi, and then x equals 5 pi over 3 plus 2n pi, and then x equals just 2n pi, or 2 pi n. Either one is acceptable. Okay, and that little dot shouldn't have been there. So go ahead and try this next example up here. Solve 3 secant squared of x minus 2 tangent squared of x minus 4 equals 0. Okay, we tried this out. I changed the secant squared of x to tangent squared of x. Either one works. If you did secant, you should still get the same answer. And so in this case, I got tangent of x equals plus and minus 1. And so that's at x equals pi over 4 plus n pi, and x equals 3 pi over 4 plus n pi. Again, remembering that this is tangent, so therefore the period is only pi. So sometimes when you square each side of an equation to obtain an equation of quadratic type, this procedure can introduce extraneous solutions. So what we're going to have to do is check any solutions in the original equation to determine whether they are valid or if they're extraneous. So find all solutions of cosine of x plus 1 equals sine of x in the interval of 0 to 2 pi. So in this case, there's not much we can do here. So what we're going to do is we're going to square each side, see if that helps us out. So cosine of x plus 1, that becomes cosine squared of x plus 2 cosine of x plus 1. And the right is sine squared of x. So I want to write one type of trig function. So I'm going to change the sine squared of x to cosine. So sine squared of x equals 1 minus cosine squared of x. So I'll change that. And then let's set everything equal to 0. So subtract 1, add cosine squared of x. So now we get 2 cosine squared of x plus 2 cosine of x, and that goes away, equals 0. So we can factor out a 2 cosine of x, and then now we're left with cosine of x plus 1 equals 0. So set each piece equal to 0, zero product property. And then really this is just cosine of x equals 0, right? We can ignore that 2, just divide it out. So cosine of x equals 0. X equals 0 here at pi over 2, and 3 pi over 2, and x equals -1 at pi. So we're looking for in the interval 0 to 2 pi. So we do need to check, and we're going to check in the original solution to equation to see if it works. So let's check pi over 2. So cosine of pi over 2 plus 1, does that equal sine of pi over 2? Cosine of pi over 2 is 0 plus 1. Sine of pi over 2 is 1. So 1 equals 1, so that is true. So pi over 2 is good. Then let's check pi. Cosine of pi plus 1, does that equal sine of pi? And so cosine of pi is -1 plus 1, and sine of pi is 0, so 0 does equal 0, so pi is good. So let's try 3 pi over 2. So cosine of 3 pi over 2 plus 1, does that equal sine of 3 pi over 2? Cosine of 3 pi over 2 is 0 plus 1. Sine of 3 pi over 2 is -1, so this does not equal. 3 pi over 2 is not a solution. So my only answer is x equals pi over 2 and x equals pi. So you have to check when you have to square both sides to see if you get any extraneous solutions. So try this last example here. Find all solutions of sine of x plus 1 equals cosine of x in the interval of 0 to 2 pi. Okay, if you try this out, you have to square both sides, and then you would get all the way down to 2 sine of x times sine of x plus 1 equals 0. Then do zero product property, and you see that when does sine of x equal 0, and when does sine of x equals -1. So then that's true at 0, pi, and 3 pi over 2. So again, we're not including the 2 pi because it's not in the interval, so we are including 0 but not 2 pi. So then we check each solution in the original. So I checked pi in the original, and I got 0 plus 1 equals -1, so that is not true. I checked sine of 0, 0, so sine of 0 plus 1 equals cosine of 0, and that is true. Then I checked 3 pi over 2 in the original, and I got 0 equals 0, which is true. So therefore, the only solutions are x equals 0 and x equals 3 pi over 2.